Hello, and welcome to episode 3 of Complex Conversations, an introduction to the Mandelbrot set. I'm your host, Isaac Bates, and today I am joined with Matilda Huggett and Luke Evans. We will be discussing what the Mandelbrot set is, how to derive it, and look at a couple properties of it. Let's get started. Matilda, what is the Mandelbrot set?
Well, the Mandelbrot set is a fractal which is plotted onto the complex plane, which we spoke about in the previous episodes. It's where you take this equation and iterate it over and over again.
How does that get us to the iconic shape?
Well, basically, you just have the C value and you pick any complex C value. You start with Z1 equal to 0, and then you just iterate it again and again and again. And if in any of those iterations, Zn plus 1 is greater than 2, then you know that that number will not be in the Mandelbrot set, that value of C.
Okay, this is a recursive relationship as we discussed in episode 1, and meaning either converges or diverges. How do we get kind of the colours though when they're black and not black?
So this is where computers come in. The computers plot every single point of the Mandelbrot set, and it checks each point to see whether it converges, diverges, is bounded. So if it doesn't diverge, it's the black parts of the Mandelbrot set.
More on that in episode 5. But how do we get the colours?
The colors will just come from the rate of how quickly it diverges. So when you're iterating through it, if you when you get to the point where it's greater than 2, you write down how many iterations it took to get to that. And then at the end, when you're actually plotting the Mandelbrot set, you can assign all of those iterations a different color. And then it's kind of like a heat map of like rate of diversion.
Right, so anything interesting about the Mandelbrot sets?
Well, in the areas where it doesn't converge or diverge, these are known as bifurcation boundaries, and they're the chaotic middle zone. They're the unpredictable build-ups of the bifurcations, and these are the spiraling parts of the Mandelbrot set.
Does this area have a name?
Seahorse Valley.
Thank you. Anything else?
Well, there's self-similarity in the Mandelbrot set in the fact that if you zoom into parts of the Mandelbrot set, you will be able to find like things that look like the Mandelbrot set, and then you can just keep going, and you'll keep finding things, zooming in more and more.
So we've got time for one more interesting detail.
It has a really interesting link to the logistics set. In the logistics set, you have these different like values for where the logistics set will like rapidly just like change its behavior. Now that's similar to the Mandelbrot set because like the distances between the numbers where it changed behavior is kind of like the distance between the different like bulbs and islands in the Mandelbrot set.
Okay. Well, that's everything for this episode. Thank you for listening, as always, and I'll see you next time when we're going to discuss Julia sets.